Hello and welcome to Andy and Iain Talk Networking. I am Andy.
And I'm Ron, standing in for Ian, who is enjoying the Caribbeans this week.
Yeah, absolutely. So, yeah, I've got Ron, our CTO at cPacket, is standing in for Ian. Ian is sunning himself on some Caribbean island, lucky devil that he is. Yeah, thanks for stepping in, Ron. Really appreciate it. And yeah,
Thank you for having me.
no problem at all. And I think, seeing as how we've got you, I think this is a really good opportunity to talk about something that maybe Ian and I are a little bit unsure about, which is the observability for AI topic. So this is an interesting one because everybody's you can't go through life at the moment without people talking about AI. AI dominates pretty much everything that we seem to be getting involved in on a day-to-day business. But I did AI back in university, like 30 years ago. But really, it's evolved so much over the years with GPUs and new technology that's used. But ultimately, all of these nodes are communicating with each other. So let's really start off just kind of at a high level. What does observability for AI actually mean, and how does it all kind of come together?
Yeah, sure. AI is, for me, it's as exciting as seeing the beginning of the internet, right? Things are moving as fast, are probably much, much faster than there. Everything is changing every day, and it certainly changes everything we're doing. So I think when we talk about observability for AI, we divide the AI workloads into three today.
Mm-hmm.
We're talking about the training that is gaining most of the attention today, and can you
Right.
run 100,000 GPUs, 200,000 GPUs, and whatnot. And the second one is inference,
Mm-hmm.
which we're seeing growing up in the next 18 months and beyond. And the third one is agentic AI, which is somewhat of inference with its own characteristics. Each one of these has somewhat different requirements and behavior, but all of them require some level of observability to make sure that you're optimizing and running and meeting the requirement. So on the training, it's really about job completion time, right?
Okay.
It's you run these very long jobs that take for a very long time,
Mm-hmm.
and you want to make sure that the network is fully utilized and it's not putting a bottleneck. Uh, Inference is a lot more about the latency
Right.
and what we measure as the P99. So the last job has to finish really quickly.
Mm-hmm.
And it's really about moving things into as close as possible to the user. And agentic is a combination of inference where you see workloads being generated autonomously within the inference engine, right? So a lot of tasks are generated right there and then, and it's a much more heterogeneous workflow than we're seeing today with more of a chat type of inference.
Okay. All right.
So,
Yeah.
I think the distinction between agentic and inference will probably go away with time.
Mm-hmm.
So, you can call it two different things, three different things.
Yeah, so when you think about kind of these three different stages, if you like, I mean, when you start talking about kind of the things that they care about, they're actually not dissimilar to some of the problems that we see in very large enterprise networks, or certainly in our finance customers. A high frequency trading where they're really dedicated and focused on things like latency and kind of microbursts. I assume are a major problem in these kind of applications, which could really impact on that kind of time to completion that you're talking about.
Yeah, there is a lot of similarity between the ultra low latency or high frequency trading that we've been dealing with over the last, I don't know, 20 years.
Long
The
time.
similarities is really about latency measured in nanoseconds, right? So you really
Right.
want to
Yeah.
know where data is being spent. Is it in the storage, in the GPU? When you move to inference and you have the workloads that are being distributed, is it, over the network?
Hmm.
And the other characteristics that really shows both on inference and in um, training is burst behavior. So a
Right.
lot of the
Yeah.
transactions are sub-second.
Hmm.
They still might cause either congestion control or packet
Offload.
drops.
Yeah.
And yeah, so there are a lot of similarities. The optimization is a little different. I think the tools that you have today to manage the congestion is a little different, but the characteristic of the metrics that you would like to see and the KPIs that you would like to measure and the tools you want to have to be able to measure are similar.
Right. Yeah. No. Interesting. So yeah, and I can imagine as you know the access becomes more commonly available to a lot of these GPUs and these kind of clusters. You know, just trying to understand what's going on within your your AI environment is going to prove a nightmare, and we're going to see speeds continue to increase from hundreds to 400 and beyond in the next generation of these clusters, and ultimately companies are developing and spending billions of dollars building these data centers, and how does that affect the observability can have a big impact on the efficiency, I guess is probably what I'm trying to get to is how can your network observability really help you with that efficiency.
Yeah, so the efficiency that you're trying to aim for is a little different between training, where again it's about make sure that the job completion time is high and
Yeah.
the throughput is really you optimize the throughput of the network
Mm-hmm.
versus latency in inference. So the I think, I mean, in general, right? Observability, what it gives you is the ability to see what's happening. And you have a lot of tools today to run the AI
Yep.
workloads, right? You can use different load balancing algorithms, different routing algorithms, different consortium are working on different approaches, many configuration parameters to configure ECN and thresholds inside the switch. And there is a lot of metrics that are coming in, or a lot of telemetry that is coming in either from switches or from the endpoints.
Mm-hmm.
Uh, what you don't have without network observability is more of an independent end-to-end hop by hop ability to
Right.
see what's going on.
Yeah.
And as you change all these parameters to come up with the best, the optimum condition, if you don't really see what's going on outside of these internal behaviors of the switches, it's very hard to guess what to do. So, we know from our customers in electronic trading that they're using the information they're getting from tools like cPacket and the ability to analyze bursts are the only real data that they have to make a decision when to expand, when links, when to expand, or when to redistribute market data feeds.
Right.
And I'm expecting that the same thing is going to happen. I mean, you can guess, and there are so many parameters that you can play forever. But if you can't really see what's going on every hop
Yeah.
between the storage to the compute to the WAN link, as you change this behavior, it's very hard to converge, and people will just do a lot of guessing.
Well, yeah,
So really,
exactly.
it's
Yeah.
essentially not flying blind, right?
No,
That's what
exactly. Yeah,
network
so
observability
you could
gives you.
find yourself trying to optimize a problem, but actually you're twisting the wrong knob effectively. So you
Right.
might be thinking the problem's somewhere in the network over here, but actually it could be an underlying latency problem, or you could have just a sheer bandwidth problem. So yeah, I absolutely get it. And kind of one of the key things I look at is the kind of really there's like 5 key metrics. So you've got your latency, you've got your overall system level performance. You need that scalability. So when you're building your observability network, you have to be able to scale from a small number of nodes all the way up to massive numbers. You need it to be reliable, and obviously you need real-time processing. So these kind of 5 things I think kind of all come together when you're looking at building kind of this cluster and this environmental observability platform.
Yeah, and I think the ROI is pretty clear when you build these clusters, right? You have to make sure that the expensive resources you have, which are GPUs,
Yeah.
are utilized,
Mm-hmm.
and you have, I mean, you have users that are pretty demanding. And when I say users, they can be algorithms, or they can be,
Or
I mean, can be
traders. Yeah.
actual people
Yeah.
or algorithms, right? Even if you're thinking about, car autonomous driving, right? They want the data just in time, which it's again very similar to what we've seen before with electronic trading. It's not only that you need to meet latency that people can perceive,
Yeah.
which is about 20 to
250.
200
Yeah. Yeah.
millisecond.
Yeah.
It's really about nanosecond, and algorithms will tell you very quickly that they didn't get the data
Yeah.
when they
Or you missed
expected.
the trade or whatever it is. Yeah. Absolutely. Yeah.
Exactly.
Okay.
So again, there is a lot of and it's the other thing that we're saying today is what they call edge AI and hybrid AI, right? You have to kind of balance between what you're going to do on-prem versus in the cloud, where you're
Yeah.
going to put the storage. So a lot of these things are everything new or everything old is new again, right? It's all the same
Everything's
buzzwords
new.
that
Yeah.
we've heard in 15, 20 years back.
Yeah.
It's just so much faster,
Yeah.
right? That's, I think, what's exciting. It's so much faster, so much bigger, and changes so quickly that it's what makes it all very exciting.
No, that's great. No, I appreciate your time, Ron. That's been great having a conversation with you. Glad we
Thank
could
you,
do
Andy.
this and have a discussion. So I just want to thank everybody for watching. Again, thank Ron for his time. It's been a really useful discussion. And again, thanks everybody for watching. Please feel free to click the like and subscribe below. It does help us, helps us drive the metrics, helps us get recommended to more people. And yeah, once again, thank you for watching. I have been Andy.
And I'm almost Ian, trying to mimic Ian. I'm not as nice as Ian. That's the problem.
We just look very smooth here. We're
We look smooth. Yeah,
optimized for
exactly.
speed.
We
Thank you,
went to the
everybody.
same hairdress. Yep.
Yeah.
Thanks.
Thanks, everybody. Appreciate your time.
Bye.